Hello class. All right, this video is for 9.4. Let's start with example 1. Use the given vectors below to graph. There are two parts. A, vector u minus 2 times vector v plus w. Who knew you can actually add and subtract vectors, right? So first thing is I'm going to try my best to graph out coordinate plane. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I were you, I would probably listen to it first and then later on your own time, listen to it and take notes again, because this unit is quite confusing. Okay, again, this unit is probably one of the most confusing units so far. So let's start with vector u. Vectors, they have to go in the right direction, in the same direction I should say, and they have to have the same magnitude. So this vector, let's just pretend that it starts here at a nice corner and it ends at a nice corner. Type up your notes. Sometimes I just can't get it to go the way I want it to go. So right now, for the sake of simplicity, we're going to say it starts at a nice corner and it ends at a nice corner. So this vector, it starts at some random place on this plane. So for me, to find out the direction, I'm just going to count the slope. Whoa, that was weird. The slope is 1, 2, 3. So down 3 and to the right 2. Normally, when I'm graphing my vector out, I would like for it to be a position vector. What that means is it starts at the origin. So for me, it's easier for me to start at the origin. So down 3, right 3 is where my vector u is going to start. Okay, so it says u minus 2v. So currently this is, ooh, that's some ugly arrow. Oh, it's awful, isn't it? Okay, so it ends right here. So this is vector u. Okay. Now it says minus 2v. So v, we are going to pretend it starts here and it ends here. V currently goes to the right and it has a magnitude of 3 units. Now normally 2 times v will give me 6 units total. Okay, so multiplying it is just normal, twice as long. But because it's minus 2v, we are going to go with its opposite direction. So it's going to end this way. 6 units going to the left. So that's what minus 2v means. Minus 2v, okay, is that vector. 6 units to the left instead of the right. Now, if that says positive 2v, you would go 6 units to the right. Continuation of where you left off. The last one is vector w, which I want to say that I want to start here at the nice corner and end at the nice corner. So now I'm just going to count the slope. 1, 2, 3, 4, 5, 6, 7. 7 up. 1, 2, 3, 4, 5, 6, 7 to the right. So I'm going to go up 7 and right 7. 3, 4, 5, 4, 5, 6, 7. So this is up 7. That's 3, 4, 5, 6, 7. So this is where I want to end, right here. Well, not where I want to. Yeah, that's adding on vector w. Okay, so start. And notice how my arrows, it's always going the same same direction as the original, unless it says a minus, like minus 2v earlier. Well, that's not really the final answer. Okay, after you add it and subtract it, the final answer is where you started and where it ends. Okay, this right here, this red vector, y'all, it's the final answer after you take vector u, you minus 2 vector v, and you add vector w. Then the red one is the final answer. Now, I will expect you will need to show me all the purple vectors there. That's your work. And then the red vector is the final answer. Okay? What do you do when you have 3 times vector u? Well, vector u looks like I'm going down and to the right, so I'm not going to need a lot of the other quadrant except quadrant 4. Now, remember earlier I said I always want to start at the origin, which is the position vector. The reason I want to do that because it's quicker for me to count. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. Earlier we said vector u was down 3, right 3. So if I'm 3 times that means I'm just going to go down 9 and right 9. So I will start at the origin. That's a position vector, means starts at the origin. You don't have to, but it's just easier. So we count at 9. So to the right 9, 2, 4, 6, 8, 9. So this is where I will end. And remember, this is the same direction. So one continuous ray. The arrow is important because it tells me the direction of your vector. And this is what 3 vector u looks like. 3 times u. Example 2. Vector v has an initial point p and a terminal point q. Write v in the form of ai plus bj. I looks like it's bold and j is bold. And that means I is in the direction of x, the vector in the direction of x, and j is the direction of y. So write v in the form of ai plus bj. That is, find its position vector. And remember, positions vector is when we start at the origin. So currently, you have a nice vector that starts at P and ends at Q. There's nothing wrong with that at all. There's nothing wrong with that at all. But to make things easier, most of the time, it wants you to find a position vector. And to find the position vector, we will now find the size of V by using a formula. x2 minus x1, y2 minus y1. Okay, so we have x2 is -6, which is this guy, minus x1 is 3, y2 is -5, minus -2. So we are going to have vector v is -9, comma, this becomes a positive, so that's going to be -3. Okay, so -5 and a +2 is now -3. Now that is your position vector. That's from the origin. So that's really the size, okay? So now it says write it in ai plus bj. Then all you got to do is write vector v equals -9 in the horizontal direction, which is vector I, plus -3j. Now let me just kind of quickly give you this as well. Some of you don't like to do the plus minus. It's totally okay to do this, okay? Just like normal algebra. So either that or that is accepted. Now what is the I and the j? Whoops, I'm sorry, the second one, can you fix that to j? The second one, what does I and j really mean? So this is what I mean by I and j. I is in the horizontal direction, okay, the vector in the horizontal direction. So if I take -9i, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if I go -9i, -9 in vector I, and then I'm going to go down 3, 1, 2, 3. So down, remember, when you add or subtract vector, you pick up where you left off. So this is where I'm ending. I started at the origin, I ended right here. So vector v is now this guy. This blue guy right here is really vector v, okay? So vector v is that guy. So this right here is -9i. This guy right here is -3j. Then when I add those together, I get my vector v. Now, simpler is even this. I can just plot a dot. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3. Can you see this right here? If I plot a dot at 9, oops, I didn't mean to have a highlighter. I plot a dot at -9, 3, then I will also have vector v. So this right here represents the dot, okay, assuming that it's a position vector, so we always start at the origin. Or this right here is when I do an addition and subtraction, and then I still end up with vector v. So either way is exactly the same. P, same thing. We're going to find, okay, the dot for vector v by using our formula, x2 minus x1, comma, y2 minus y1. So vector v is 2 minus -1 is really 3, and same thing for the y. Now, it doesn't want you to leave in that form. Technically, there's nothing wrong with that form at all, but it wants to leave you in the addition form, which is 3 in the horizontal distance plus 3 in the vertical distance that I would end up with my final answer. That's the starting from the origin. Example 3. Find the magnitude. Okay, your book uses the double absolute value. Some books don't, so don't worry about it if it doesn't, okay? For us when we write it by hand, you don't have to use the double bar. So find the magnitude of v given vector v is negative 2i plus 12j. So absolute value is a squared plus b squared all under the radical. Well, a is negative 2, so negative 2 squared plus 12 squared, which is 144. I'm sorry, no, 148. 148 is 4 times 37, so this is going to be 2 rad 37. So this is the magnitude, which is the size of vector v. Example 4. I am giving you vector v and vector w. Vector v is negative 2i plus 12j. Sorry, this is supposed to be both. Okay. And vector w is 2i plus 3j. Well, find the magnitude and then subtract them. So, well, the magnitude of v is already found, so I don't need to find that. Okay, we just have to find vector w. The magnitude of vector w is big radical a squared plus b squared, which is now 2 squared plus 3 squared, which is going to give me 9 plus 4 about 13. Okay, so now let's subtract those. Vector v minus vector w, which is 2 rad 37 minus rad 13, and looks like that is as far as you can go in terms of simplifying without a calculator. If you have a calculator, you can also punch it in and give me the decimal, but no calculator is perfectly okay. You just need to understand how it's done. Example 5, find the unit vector in the same direction as v. Okay, and then I'm giving you v is negative 2i plus 12j. Can you guys see that all these v's are like the same? It's for a purpose, so that way we don't have to calculate the magnitude over and over and over again. Okay. Well, unit vector, the formula is unit vector, which is u vector, is vector v divided by the absolute value of vector v. And we found the absolute value of vector v already, which is the magnitude. We found it up here, 2 rad 37. So what you're just going to do is take vector v, negative 2i plus 12j all over the magnitude, which is 2 rad 37. You have to simplify this out. So here we go, negative 2i divided by 2 rad 37 plus 12j divided by 2 rad 37. Now from here, we're going to go a little bit further in simplifying because I can cancel those guys out. So on the numerator, I really can have negative 1 over rad 37 in the I direction. And the 12 over here can reduce that to a 1 and a 6. So now I will have a plus 6 over rad 37 in the j direction. Let's rationalize that by multiplying bottom and top by rad 37. So are you ready for our answer? The unit vector is negative rad 37 over 37 in the I direction plus 6 rad 37 over 37 in the j direction. And this is our unit vector of v. Okay, has the same direction as v, just a unit vector. And this is going to be example 6. Here we go. Now again, if I'm going too fast, that's the nice thing about video notes is you can ask for it to be paused, or you can pause it if you're on your own. Okay. Write the vector v in the form of ai plus bj, given its magnitude already and its angle. And the angle it makes with the positive x-axis. Okay, so this angle right here will allow us to understand its direction. So this is really direction angle. Okay, so how do we find vector v? Vector v, class, is always the magnitude times cosine of this angle. Sometimes we call it alpha, sometimes we call it theta. So it's not really, and then we're going to multiply to in the I direction plus sine of alpha. Well, let's use alpha since it's using alpha. Sorry. Cosine of alpha in the I direction plus sine of alpha in the j direction. Okay. And we've seen this before as well. Remember in the polar complex form, we had this, and I just want to bring this up for you. Remember we had z equals radius times cosine of theta plus I sine of theta. Well, earlier it was polar form, so we didn't have vector I and vector j, but it's quite similar. The r was still square root of x squared plus y squared, so they're kind of related to one another. Okay. All right, here we go. Ready? So first we gotta convert it to, we have to plug it back into here. So magnitude goes here, angle goes in those locations, and then we'll simplify that out. Vector v is, you have a magnitude of 6, so we'll write 6 cosine of 30 degrees in the I direction plus sine of 30 degrees in the j direction. Well, cosine of 30 degrees is rad 3 over 2 in the I direction plus sine of 30 degrees is 1/2 in the j direction. Yes, you do have to simplify because it says v in the form of ai plus bj. Remember, this I is not the same as imaginary I, okay? This is a vector I. So from here, we are going to distribute the 6. So vector v is 6 times that. The 6 and the 2 will cancel out, will give me 3 rad 3 in the I direction. And please don't be lazy. Make sure the I is a vector. And then 6 times 1/2 is 3 in the j direction. And looks like this is definitely ai plus bj. And we are done with that vector. Example 6b. Very similar. We are now going to do the same thing. We already have the magnitude. We're going to put it right in the front. So 14 times cosine of 315 degrees in the I direction plus sine of 315 in the j direction. And remember, the angle is going to allow me to determine what direction this vector is going. Then from here, we're going to simplify cosine of 315, which is going to be 14 times, that's going to be in quad 3, so cosine is positive 2 over 2 in the I direction, plus in quad 2, sine of 315 is going to be negative rad 2 over 2 in the j direction. We will definitely distribute the 14, so now we have 7 rad 2 in the I direction. You can do a plus and a minus is a minus, there's no big deal at all. Okay, so 7 rad 2 in the j direction. Now this is definitely vector in the ai plus bj form, and that right there, my lovely students, is the end of this video. Okay, again, if it's too fast, please do ask for it to be played again, or you can play this on your own when you have some extra time and take notes again the second time. Have a wonderful day.